So if people have seen me here before, you'll know I don't much like slides. And so this whole presentation will have one slide, which you'll get to see later. But instead, we're going to go straight to the terminal here. And I'm going to show you a little bit about Ansible. Now, how many people here think Ansible is a configuration management system? Because of how I phrased that, I know only half of you raised their hands. No, it's not a configuration management system. Ansible is an automation system. Now, in a bunch of cases, automation can include configuration management. But if all you're doing with Ansible is configuration management, then you're missing out on a lot of its potential. And so I'm actually going to show you how to use Ansible for automation. And the nice thing about Ansible as an automation system is that it is so easy to learn that in half an hour, I can show you enough to get yourself in serious trouble. So, I got my local container here with all of my Ansible and plugin installed on this, right here. And we're going to actually get going with some stuff. Now, one of the first things to understand about Ansible is that it's an agentless system based on SSH. That is, it doesn't require any Ansible components installed on the systems that you are targeting with it, just on the system that you're going to run your Ansible scripts or playbooks or whatever from. What it does require is that you have SSH access to all of those systems. So the advantage of that is you're not installing agents on all of these different servers and that sort of thing to actually manage your relationship. The bad thing about that is that you do generally need to set up SSH stuff yourself. Now, on some systems, I do a lot of stuff on Amazon Web Services. And when you deploy new instances there, you have to put an SSH key on them. So that's pretty easy. But I do need to go ahead and get local access to that SSH key. So I'm going to start up SSH agent. And then I'm going to add my Amazon credentials. Hold on. Oh, right. That's why. Okay. So you need to go ahead and now the easiest way is to actually have an SSH key that that you have installed on whatever systems you're going to manage that you can go ahead and add to a keychain. If you don't have that, you can actually set up Ansible to take passwords for SSH, and that works. It's a little bit more cumbersome, and I'm not going to show it to you today, but it's there in the documentation. Now, once you've actually set up an SSH key that you can access the other systems with, you need to actually tell Ansible which systems you have. Now, if you're just automating stuff on the local system, you don't actually have to give it anything. But most of the time, if we're running Ansible, it's because we want to automate stuff involving multiple systems. And so in that case, we need to actually add what's known as an inventory file, or sometimes as a host file. So I've got one here. Wait, actually, I had to show you something else first, which is I'm not on the correct lesson. So for the tutorial here, which you can actually try yourself later on, or better yet, after I've cleaned it up, it's actually done as a series of git commits as different lessons, because we're going to go from simple to complex. So this is lesson 1. And so now we're going to look at the inventory. And this inventory file is really simple. I've got one group called Docker build. And later on it'll become clear why I named the group that. Groups can be any string that you want to, although there's limitations on characters, special characters and that sort of thing. And I've got an IP address. You can also use DNS names here if they work for you. In my case, an IP address was more convenient. So I've got that one thing, and that is, as you might guess from the IP, it's actually an AWS host that's running right now. We've got the one AWS host right here, Ansible Docker build running CentOS 7. So I've got that one inventory, and so now I actually want to do something with it. Well, the first thing is let's verify I can connect, right? So now, what I've got here is I'm calling the module ping, and I'll explain modules in a minute. I've given it my inventory file, and then I have to log in as the user CentOS. Now, we've got that. Oh, let's verify the SSH key. That's a little annoying. I'll show you in just a second how to get rid of that. So there we go. I pinged it. That was exciting, wasn't it? Okay, well, first of all, let's get rid of that thing right there. So one of the things that Ansible takes for just about everything is you can put a whole bunch of variables, some of which are variables for your own use that can be just some random string. And then a bunch of variables actually mean something because they're built in. And these are what are known as host variables because they apply to a particular host. And I'm telling it actually two things. Number one is I want it to log in as the user CentOS. And number two is the special become thing. And become is generally shorthand for sudo. But we don't say sudo anymore. It's replaced, actually, old versions of Ansible actually specifically was sudo. Because depending on the system you're targeting, there may be a different mechanism for escalating your system privileges. So I've told it I'm going to log in as the user CentOS, and then I want it to escalate its privileges to root when it logs into this particular system. So there's my inventory. And then if I actually have that, I now don't need to give it all these extra flags. Oops. Oh, I still need the inventory flag. So I want to get rid of the host key checking as well. And that's where Ansible config comes in. This is a configuration file that's sort of global for how you use Ansible. There's a few things that you actually set here. There is generally, if you've installed Ansible on a system, there's going to be a system-wide Ansible config. You could actually edit that file in place. But I like to actually have a different one in each one of my projects because I often want to have some different settings. So in this case, I want to do a couple of things. This way I won't get that annoying SSH check message for further ones. Okay. And now I should be able to just ping my group without needing to do anything else. So that's just really a little bit of cleanup here. Now, the first thing that you can obviously do is you can just use Ansible to actually kind of wrap SSH for you and to run commands on the shell via SSH to one or more hosts. So so for example, I can tell it, hey, I want to install Docker on this other host, right? So it's going to go ahead and install Docker on the target host or all the hosts in the Docker build group. But that's, and all I'm doing is just passing an SSH shell command to the remote thing. So you can obviously do that with Ansible. That's sort of the most primitive way to do it. And this is certainly not a very good way to actually install packages that you want to on target systems. So we actually want to do this in a more sophisticated way. So I'm going to go on to lesson 2. So this is why I said that wait for me to clean up the thing a little. Now, I mentioned that one of the things that Ansible has is modules. So what modules are is someone else has written a bunch of code to automate a whole bunch of functionality that in order to do things with Ansible, in order to carry out actions without needing to go through sending a bunch of shell commands. So for example, if one of the things that I'm going to do later on in this is I'm going to do some Amazon Web Services automation, and that all falls under cloud modules. And as you'll see, there's like already, there are a lot of AWS automation modules. As well as automation modules for many, many, many other things. I think currently in the core set, there's over 400 different automation modules. Plus, the Ansible project recently launched this thing called Ansible Galaxy. And Ansible Galaxy is sort of a GitHub or Docker hub for Ansible automation modules, specifically so that the general community can upload their automation modules to there and other people can download them and maybe improve on them. So almost anything that you would actually want to do with the system, you'll probably discover that there's already a module for. So let's show you a couple of simple modules. Now, I showed you installing something by executing a shell script, but that's not very good, and most importantly, it's not very debuggable, particularly if you think about installing a particular package in a chain of like 800 other things you're doing. So we actually want to use one of the packaging modules. Okay, so now I'm calling the yum module here. And the yum module installs things on CentOS and RHEL systems because it calls yum. But I have to actually give it some parameters. Now, this actually demonstrates a couple of things. One is sort of a better form for doing things by using modules. The second thing is that most modules are written to be idempotent. That is, they're written to not do an action, but assert the way that things should be. So instead of telling it install Docker, I told it Docker ought to be installed, which means that if Docker already is installed, it does nothing. And that's very important because whenever you're automating stuff, you're often going to want to run that automation over and over again, and you don't want it to take a lot of actions that aren't necessary because sometimes taking those actions can actually be destructive if you do it repeatedly. So, and I can do more than just install things, though, because I can say things like, okay, well, so Docker's installed, I want to make sure it's running. So there we go. Docker started. Now you see, we get different output here now from the module. The first one told me that it was already true that Docker was installed. And the second one told me that it actually changed something. Yep. Now, you saw before I just sent this sort of shell command. And that's actually the default thing that Ansible does if you don't give it a module, is it sends stuff by the command module, which is similar to but not identical to the shell module. And that's just, again, sending a shell command and giving me standard out back to the calling system. Pretty simple. Now, these ad hoc commands are nice, but I can only do one thing at a time with the ad hoc commands. And on top of which, it's not very repeatable. If I'm wrapping this all in a bash script, it's still very hackish. So Ansible actually provides us with a different abstraction for calling a series of modules with parameters, and that's called a playbook. Simple enough, right? So we're going to go ahead. So here's a very simple playbook. So this is just targeting, again, our Docker build group of hosts, which is only one host in there. And first I've got a variable in here, and the variable is the name of the Git repository for this tutorial. So one of the things that playbooks accept is variables. Now there are some built-in, there's a list of built-in variables, like I said, and you can also create and assign your own variables. And then I've got four tasks. I've got 4 tasks in here. So one is to install Docker, one is to start Docker, one is to install Git, and then the last one is to check out that Git repo. And then here is where I substitute in that variable for the name of the repo. And the reason why I'm doing that even in a single playbook is I'm likely to change the name of that repo in the future, and therefore I want it at the top in a set of variables where it's easy to find. Now, do people recognize this syntax for referencing variables? You know what it's from, right? It's Jinja, yeah. Yeah, so yes, Ansible does use Jinja templating for most of its substitution and everything else. And then, so I can just go ahead and run that, and it'll give me a bunch of feedback. It's a little bit nicer when you haven't blown up the text all the way. And you can see that it actually provides me a nice summary of this, right? Which is, it ran this, it checked 5 things that were things I had told it to do, right? And those were already okay. And then one thing it had to change. And if it couldn't reach a host, we'd have a count in unreachable. And if something failed, we'd have a count in failed. And this is your sort of output for whenever you're doing an automation run. Okay, so that's a simple playbook, and you can already do a lot with a simple playbook. But let's actually make that playbook a little bit more sophisticated and show you a couple of other techniques. So, again, this is automating our sort of Docker build system. But now I actually want it to do more things, because I don't just want to install Docker and have it check out a repo. The reason why I call this a Docker build system is I'm actually going to have it build a container for me. Because that's or a container image for me, and upload that to Docker Hub, because that's why I have the system there, right? And so I'm going to fill in some variables. What's the name of the image I want it to build? What's my email? Where's the repo and that sort of thing? A couple of paths that might be things that I want to change later. So, and then we're going to do the installation. But previously, where I had each installation as a separate task, I'm now going to take advantage of the fact that we can put little loops in the playbooks. And so this little loop is called a with items that automatically puts anything in the list into the default variable of item. And so it's going to install this, and this means that I can then just have this YAML list of packages that I want to install. I'm going to take the same set of actions on the back end, but it's a lot more convenient for writing purposes. Second thing is to show you another module, template. And this is a module you're going to use very frequently, which is all it does is it takes a Jinja template, Jinja 2 template, and it renders it according to whatever variables are currently in scope in your Ansible run, and then it pushes it to a destination on the target system. Pretty simple, but something that you end up doing a lot in automation. And then we're going to go ahead and check out the Ansible repository. And again, we're putting in the Ansible name, and we're telling it where to drop it on the foreign system. And then we've got this handlers thing. What is this handlers thing about? Well, see, we've got these 2 lines that say notify. And what those lines that say notify mean is we have, we're going to push a template. And what we're saying, the notify fires whenever something happens. Whenever there's, so I showed you before that one thing was changed. So if this task results in a change, then it's going to trigger that notify. So if I've changed the Dockerfile template, it's going to trigger the build Docker image action. And if I change the contents of the repository, it's going to trigger that build Docker image action. And the build Docker image action looks like another task, this using the Docker image module, and it tells it to build a Docker image. So let's go ahead and run that, hey? That'll take a little while to run because building a Docker image takes a little bit. And you notice here, we've changed writing the Docker file, and we've changed checking out the repo, which means it's triggering this build Docker image handler. Now, one of the other things you'll see here is a good practice with Ansible repos is go ahead and give your tasks very explicit names. You know? Give them nice human readable names so that when something breaks, you'll know exactly what step braked. Not like, you know, step 16, which won't really help you in debugging at all. And so there we are. It went ahead and built a Docker image on the external system. Now, oh, okay, so my first mess up in the demo here. The problem was that I didn't actually rebuild that AWS instance from scratch because it was actually supposed to fail on that last step. Because it was supposed to fail to log into Docker Hub. So the so if you actually try it following along with that, you'll actually get a failure message because it can't log into Docker Hub. So I'm going to show you what I did about that previously because this is an important capability for you to know about, which is secrets. So, I mean, one of your problems with configuration management and other stuff is you have lots of passwords. And as part of automating a system, you have to use those passwords. But you don't exactly want to check them into your configuration management repo, which might be on a poorly secured or even a public system under third-party control. And Ansible gives you a very easy-to-use abstraction for that, which is Ansible Vault, which just encrypts files for you. Now, whatever password you use here, definitely remember it. Maybe have it in some external secure system because you can't retrieve the contents of this file without that passphrase. And then I can go ahead and create some variables here. So, okay, and then we have an encrypted file. And the lovely thing about that is, if you screw up and you accidentally commit that file into your public GitHub repo, somebody needs to go through cryptography cracking in order to read it. So it's not the disaster it would be if you checked it in plain text. Now, that's not the actual file I'm going to use because I wasn't going to show you all my Docker Hub login. I have a separate file here called pass, which is the one that I'm going to go ahead and use. So now if we look at the playbook, you'll see, first of all, we put in a reference to that pass.yml file. We've actually added a second handler down here called Docker login in order to log into the Docker Hub. So now, one of the things that you'll see will happen when we actually run this playbook is I'm going to get prompted for my Vault password. Now, here's an important limitation. You only get prompted for the Vault password once, or passphrase once, which means that for all of the encrypted files that are going to be used with a single automation repo, you need to set the same passphrase. There's a to-do to actually make it different than that, but that's how things work right now. So now again, we're going to go ahead and build the Docker image, and it's going to upload it to Docker Hub. So, okay. Okay, now, what I've showed you right now has been a very simple playbook. But you can imagine when you get up to automating huge systems with dozens of different actions on dozens of systems, you don't necessarily want them all in the same file, because that file will get thousands of lines long. And so one of the things that Ansible has is it has some built-in abstractions that go into predefined directory locations. So let me actually show you those. So one of them here is some of the built-in variables. So there's this group vars directory right here. And basically, if you have a group vars directory in the home of your automation directory, then you can have files full of YAML variables, just variable assignments, and they're named after the groups. So I've got one named after that Docker build group. And plus you can have an all group that applies to any run that you make for anything. The other important thing is this roles thing. So roles are basically a call out to a set. Basically, you're basically calling out to another playbook that's been decomposed into a bunch of directories to run inside the playbook that's calling it. And so you put your handlers in their own file in the handlers directory, you put your tasks in their own file in the task directory, you put templates in a templates directory. It also supports directories for the other kinds of Ansible objects. You can see more in the documentation. And then these get automatically included in your run if you've put them into this kind of directory structure. So it's an easy way to organize your stuff. So let's go ahead and run that, because there's no point in doing it if I can't prove that it works. Ta-da! Didn't do anything because we haven't changed anything. But if you actually want to look at that, all I've done is broken down the YAML files. So this is just that segment that was under handlers in the main playbook. And what's happened to the playbook in the meantime is the playbook's gotten very short. See that? All I'm telling it is, for the group of hosts that is Docker build, I want to include that password file. And the reason why I'm including that password file separately is I like to put my password files in a different location apart from the role stuff, so I don't accidentally check them into public GitHub. And then we're going to execute that role. Now, obviously, we could execute multiple roles. So and that executes that. Now, with a playbook that's simple, I wouldn't want to do anything that complicated. But the whole point of automating things is so that you can do long, complicated sets of things without having to do them repeatedly. So now I'm going to show you some AWS automation. So we have this Docker build system that's building an image and uploading it to Docker Hub. But the whole point of that is, whenever any of the inputs change, the Docker file changes, the repo changes, I want to rebuild the Docker image automatically. And then I want to spin up a new AWS instance running Atomic Host, because that's one of the things I run on, which is a container operating system. And then we're going to start Docker on the Atomic Host, and then have it download the Docker image and run it and start up a website. So again, a whole automation toolchain, a very simplistic version of something that you might do in order to automate your own continuous delivery framework. So I'm going to go ahead and kick that off. And then after I kick that off, I'll actually show you the parts of it because it takes a while to run. So we've got a bunch of stuff. So if we actually look at the playbook is not all that much longer. Sorry, I commented this out for speed reasons. In the complete playbook, we would still have this section uncommented. But it's commented out right now so that so it won't go through checking all those things because we've already run them. And then I've added this other thing here, which is this play is on localhost. It's loading my AWS passwords, which are another encrypted file. And then it is launching the create EC2 role. Now, the reason I have to launch that on localhost is that the EC2 server I'm spinning up doesn't yet exist. And for that reason, I run it on localhost, use my AWS credentials to log into the AWS API and tell it spin up a new EC2 host. And then for that host, once it's spun up, it will be added to the web hosts group, and we will run the web configuration role on it. Now, what do all those things look like? The AWS YML file is just another encrypted file, and this time it has my IAM credentials for AWS in it. And then if we actually look at we actually look at this task, we have this long, complicated task for doing EC2 stuff. Now, it is a little complicated if you look in this. This is because the EC2 API is very rich and has a lot of details and a lot of required fields for doing things. If you try this on your own, you're going to need to have your own AWS account, and you're going to need to look up a lot of things like your default VPC subnet, et cetera, to actually fill it into a lot of the variables. And then we actually do a trick here, which is we create the new instance, we create this temporary EC2 group, and that's so we can loop through it and then add the hosts that we just created to a new group called web hosts so that we can configure them. And that way I can do this all in one script because the web hosts were not in the inventory because they didn't exist when I started the playbook. The drawback to doing this is that I've now created a playbook that is not idempotent. Every time I run this playbook, we're going to create a new instance. And there's some other things, like if you're creating two instances, you actually want to poll SSH and wait for that to come up before you proceed in the playbook. Otherwise, succeeding actions will fail because they can't connect. Oh, and where those variables are is so one of the other default variable paths is host variables, which get attached to individual hosts, and I've attached these to localhost. And so I've got this set of variables for my EC2 stuff in localhost. Let's see, what else did I want to show you from that? And so then this, once the new system is spun up, it just starts Docker, downloads the container, runs it, channels it to port 80. So let's see if that's actually finished. Nothing failed. A whole bunch of things changed. So if that's correct, and here's the IP of our new host, we should have a web page there. And now I'm ready for questions.